working with partial fraction decomposition, other than sounding very fancy, is important to you because when you get to some forms of calculus, being able to work with two different fractions instead of a very complicated single fraction will be helpful to you. So usually, if we had a situation like this, we'd find a common denominator in order to combine it, right? So what did we multiply the first fraction by? X minus 4 over itself, absolutely. Maybe some parentheses. And what would we multiply the second fraction by? X plus 1. Lovely. And so your common denominator would be x plus 1 times x minus 4. And your numerator, you would just distribute your 8, distribute your what kind of 5? Negative 5. Oh yeah, that's a negative 5. So 8x minus 32 minus 5x minus 5. And then you would combine those like terms. So 8x minus 5x is 3x's. Negative 32 minus 5 is negative 37. So that was unit. We did that stuff in unit 2. What we're going to be doing now is starting with the complicated fraction and breaking it up and decomposing it into 2 or 3 or 4 little single fractions. What you'll notice about every one of our situations is that this process is going to work when we have a bottom-heavy fraction. So all of our fractions are going to have more x's in the denominator, a higher degree in the denominator. We're also going to be able to do a lot of factoring, and we're going to have to do a lot of factoring. The processes that we're going to use, the process that I'm going to show you today, is what is going to work when we are able to factor our denominator into little lines. So we can factor into kind of what we started with here, x plus 1 and x minus 4. Or if you flip forward in your packet, you're going to see we're going to have more complicated situations. We're going to have things that are not factor. We're going to have multiples, and then we're going to have situations that are not factorable.
Sorry.
Oh, bless you. All of these, like, none of this math is very hard. It's very process-based. And I'm thinking that if as long as I feel like we're all kind of on the same page, I'm thinking we'll end this unit with being partner. So that's where I'm thinking it's going. So here's our process for this. The first thing we're going to do is factor our denominator. I don't really care to factor the numerator. I'm going to factor the denominator. So, two numbers that multiply to negative 18 and add to 3. Positive 6 and negative 3. Lovely. So what I want to do is this. I want to take this complicated fraction and I want to turn it into two fractions. I'm basically going to uncommon the denominator. I'm going to make an uncommon denominator. I want this instead. Something over x plus 6 plus something over x minus 3 combined to give me that. We're going to call those, honestly, you can call them heart and star or smiley face and frowny face. They're just variables. I'm going to call them A and B. And the textbook and Math Excel calls them A and B. And everything I've seen online when I've searched this calls them A and B. So our second thing is to break it up. So we have our two fractions. The third thing we're going to do is my favorite step, just in case you're wondering, is clear the denominator. I actually, when I wrote this unit a couple years ago, I introduced this into the curriculum because it was needed. And I did the whole unit, every key, from first to last without clearing the denominators. And then I took it to our AP Calc teacher at the time, and I was like, it's easier if we clear, if I teach them to clear the denominators, right? And he was like, oh yeah, it is. So I did everything with like finding common denominators and leaving the fractions. And then I went and rekeyed everything, and I was like, that is so much nicer. So clear the denominator. Take it from someone who did it. Clearing the denominator is lovely. So what I'm going to do, just kind of for ease of your looking at this, I'm going to recopy. And this is something that many of you will not show this step after this example, because you'll just kind of be able to see it. Some of you will want to show this step because you need to. Some of you will want to show this step because you're completely type A. So when we clear the denominator, we're going to multiply each term by our most complicated denominator. Our most complicated denominator is x plus 6 times x minus 30. We're going to do that everywhere. And I'm really going to write it everywhere this time. And you can decide if you need to write it everywhere next time. All right, so if I multiply the stuff that's on this side over here by x plus 6 times x minus 3, I have x plus 6 over itself, so that's 1. I have x minus 3 over itself, so that's 1. So all I'm going to be left with is 8x minus 42. Again, we're clearing the denominator, so if we are saying we're going to clear the denominator, it better be gone after this step or something has gone wrong. When I multiply x plus 6 times x minus 3 with a over x plus 6, the x plus 6's cancel. So what I'm left with is a times x minus 30, right? It's going to be left with, in the numerator, what it did not have in the denominator. That makes sense if you think about, like, we're undoing the common denominator. Okay, x minus 3 cancel here, so I'm going to be left with b times x plus 6. And now I'm going to write that mess out. Back in this pretty navy blue color that I was The problem with this is that we can solve a system of equations, right? We're used to having multiple variables. We did a whole little unit on system of equations, but to solve for multiple variables, we need multiple equations. And we only have one here. We have one equation and we have 3 different letters, or if you did happy face and frowny face, we have 3 different variables here. So the idea, we want to find A and B, they are constants. Once we find A, we can plug it in. Once we find B, we can plug it in. They're not really variables, we've got to find them. X is a variable. We can make X anything we want. So you can be as creative as you want. What I like to do is make these guys 0. If I make x minus 3 0, what happens to A? It's gone. And now my x has a value and I can just solve for B. So this is how that looks. If I'm going to make this little guy 0 right here, what does x need to be? 3. Okay, so I'm going to label out here. And everywhere I have an x, I'm going to put in a 3. Oh, and this is a with calculator unit. Again, there are a lot of places where you can skip steps. Just be careful about the steps that you're skipping because there's a lot of math going on. And this is one of those places where I teach this unit for two reasons. One, because it's useful to you when you take your second semester or second year of calculus. The other reason I teach it is because this is algebra precision all day long. None of it's hard, it's just you have to, like, you're practicing that precision everywhere. Okay, so what is 8 times 3 minus 42? Help me out, check my work. Negative 18, thank you, that's what I got as well. And then I have this zeros out. So how I usually show this, if you're looking at my work, I would do something like this. Hey, that's 0, so that whole thing is gone. Right? And 8 times 0 is going to give us 0, so that term is gone. If you want to write a times 0 here, you can absolutely do that. I just like to make it go away. All right, and then I have b times 3 plus 6 is 9. So then I have 9b. Oh, that's nice. So b is negative 2. And what we're doing is we're just filling in these blanks up here. So the number over x minus 3 is going to be negative 2. Now we need to find a. So you can plug in b, but what I'm actually going to do instead is just zero out b. How am I going to zero out b? What am I going to put in for x? Yep. So 8 times negative 6 minus 42. And what I'm looking back at is this right here. Don't get distracted by your work that you did with that x equals 3. I'm going back up to that kind of mastered there. So a, and my x is 6, so 6 minus 3. And my b I'm zeroing out, but I want to show it just to make sure that it actually worked. So 8 times negative 6 minus 42, I got negative 90. Is that what you got? Oh, sorry, look what I did. How about a negative there? That won't work. Negative 3, or negative 6 minus 3 is negative 9. And this guy, 6 minus 6 is 0. So b times 0 is 0. So a is 10. So here's what we just did. We started with that complicated fraction that looks like this. 8x minus 42. And we decomposed it. We broke it down into the two fractions that are equal to it. In our number, and here's where this matters. A has to go over x plus 6. So 10 over x plus 6 plus negative 2 over, and it was x minus 3. So that is your final answer. Really, just this part right here is your final answer. I check these every time. Here's how I check it, especially since you have your calculator. Put this guy into your calculator. If you have a TI-84, you put that fraction in as y1. If you have a Inspire, you put that in as f1 of x. Just put it in as your first equation. Put this guy in as y2 or f2 of x. graphs should look exactly the same. We should lay right on top of each other. Okay? If they don't, they're not equivalent. What we're doing, we're just breaking it into an equivalent fraction situation. Okay? So I would double check that way every time. I mean, I'm going to give you answers on the board for a lot of these, but if you're doing Math Excel, before you hit go, graph it. Okay? If you're doing a quiz, before you say you're done, graph it. Check your work. Okay? So you get the exact same graph that you'll lay right on top of each other. If they're off, even by a little, something went wrong. All right, let's do number 2, and then I'm going to have you practice. I'll have 2 examples for you today. The first thing we need to do is factor the denominator. Do it, factor. So I got x plus 4 and 2x minus 1 as my denominator, so that's how I'm going to break it up. It doesn't matter which way you label them. The thing that matters is that the numerator goes with the denominator. So I actually just labeled these backwards of what I did on my key. So if you were to pull up the key on Canvas, you'll see that I put a over 2x minus 1 when I did this problem went over. That order doesn't matter. It just matters that the number that we find for this guy is matched with that is over the x plus 4 in the end. All right, now let's clear our denominator. I'm going to get rid of that factoring work. And let's clear our denominator. What am I going to multiply everything by? Yep. X plus 4 and 2x minus 1. I'm going to write it with every term. If you only need to write it once on each side, that's fine. I like to show what I'm crossing out. So we know that x plus 4 times 2x minus 1 is equivalent to that. So it's going to cancel that whole guy. Left with 9 minus 9x. My first fraction, my a fraction, I'm going to cancel the x plus 4s. My b fraction, I'm going to cancel the 2x minus 1s. Again, if yours is a little bit different, that's okay. As long as you have the same order does not matter, as long as your numerators end up paired with the right denominator. I always take the path of least resistance if I can. So when I look at this, the thing that takes less brain power for me is I'm going to zero out b first because I just see it like as a whole number. What am I going to make x equal to if I want to zero that out? -4, absolutely. I'm going to zero out b so I can solve for a. Suggest that you kind of do the big groups all as one in your calculator. So use the parentheses in your calculator and kind of do as much in one step as you can. Do that whole thing in your calculator. Do this whole thing in your calculator. I think there are just a lot of sign errors that you can make. And if you're gonna lean on your calculator anyway, do it so that you can be the most precise. Or if you're thinking like, I think I got 45 here, when you're double checking your numbers in your calculator, just put them in as big groups. So here I did get 45. Here this is -8 minus 1 is -9. And this guy zeroed out, right? We did that on purpose, that was wrong. So I got -5 as my A here. Later, when we're doing practices, more complicated problems and more complicated practice problems, we are going to have to plug in that A. Like if we have A, B, and C, at some point we're going to have to use that A to find C. So making sure you're precise on finding that first value can kind of make it or break your problem. All right, now what am I going to plug in? How am I going to zero out A? 1/2, yep. So 9 minus 9 is 9. Oh, it's plus 4. So 9 minus 9 times 1/2, what'd you get there? 9/2, yep, or 4.5. Either one's fine. This zeros our A out, that's 0 there. 0 times A is 0. What's this right here? 4.5. What's 9/2 divided by 4.5? 1. You're not always going to get nice numbers like these. You will for a bit. Again, you guys know I can't guarantee what iteration of the problem you're going to get on Math Excel. So this can be a little nastier. You will see some fractions on this practice even, and I'll show you how you can read those in the fractions. You can do a fraction over a fraction. So A goes over x plus 4, so A was -5. And B goes over 2x minus 1. And that is your final answer. Again, I always suggest that you graph your original equation and your final answer together. The other way that you could double check, if you would like, is find a common denominator and combine. If you multiply this one by x plus 4, multiply the other one by 2x minus 1, combine your like terms, then your numerator should be 9 minus 9x. I have checked my work covenant as well. I'm a crazy person. You guys know that way. There are your practice problems. Go ahead and give them a try. You're going to want to switch to paper.